Alright, so we're going to answer some calculus questions involving mostly the integral calculus, but of course we're going to start with implicit differentiation, as you can see from question 1. So this is tutorial sheet 7. Okay, so it doesn't matter where you are, these questions are going to help you understand these concepts. Okay, if I show you the second page, you see we actually have more integral calculus questions. Okay, very interesting questions ahead of us. So we're going to get started with the very first one. Okay. Question 1 says use implicit differentiation to find the dy dx of each of the following. So that's what we're trying to do here. So implicit differentiation. So this is a case where you cannot make y the subject of a formula. So how do you go about differentiating such an equation? So we'll start with the first one. We have x squared plus y squared plus 8x minus 2y minus 8 is equal to 0. Okay, so I'll give you an idea here. So the shortcut, or the best way, or the simplest way of actually approaching these questions is differentiate x squared normally, and then when you differentiate something like y, it will be 2y now multiplied by dy dx, showing that you've differentiated it in respect to x. Okay, for x squared, that will just be a 2x. That's a normal way of differentiating, right? Okay, so if you're new to all this and you want a bit more detailed explanation, check in the description for a video to our introduction to implicit differentiation. Okay, so x squared, the derivative of x squared is 2x. Derivative of y squared is going to be plus 2y. Now I said you're supposed to add dy dx when you differentiate y. Now look at the derivative of 8x. That's just going to be 8. Derivative of negative 2y is going to be minus 2. Now since we differentiated y, don't forget to add dy dx. Derivative of a constant minus 8 just gives us a 0. Equal to 0. Okay. Now at this point, what you ensure that whatever is having dy dx remains on the left. So we have 2y dy dx, and then this part as well, minus 2 dy dx. Everything else goes outside. What is everything else? That's the 2x, that's the 8, the constant, so we'll say negative 2x minus 8. So you might guess here, factor out dy dx, that's what we're interested in finding. You remain with 2y minus 2 equal to negative 2x minus 8. At this point we can just divide by the 2y minus 2 on both ends. So we're going to have our dy dx being equal to negative 2x minus 8 over 2y minus 2. So that's it for the first one. That's how you differentiate it. Okay, so if you've still not gotten the idea after looking at this one, feel free to watch the introductory video to this topic. Otherwise, I'm going to explain again in the next question. So for our second question, what we have 2x squared plus 2y squared minus 3x plus 2y plus 1 is equal to 0. Please feel very free to just pause video and try out this question. So the derivative of 2x squared is going to be 4x to the power 1. What do you do when you're differentiating? That's not the point of this video. I believe by now you know how to do that. So 2x squared implies multiply the power 2 times the base 2 gives you 4. The power reduces by 1 becomes 4x. This one equally is going to be 4y. Now we always add a dy dx when you differentiate y. Remember what we're differentiating is y in respect to x. So if you differentiate y again in respect to x, you're supposed to add the dy dx. Okay, derivative of negative 3x is just a minus 3. Derivative of 2y is a 2. Now don't forget we've differentiated y, so we add dy dx. Derivative of a constant 1 is just a 0, so equal to 0. What do we do at this point? Every part containing dy dx remains, so for y dy dx plus 2 dy dx. Well, we can add the additive inverses on the other side. Okay, so we have got 4x and minus 3, so we have to be positive 3 and then minus 4x on the other side. Okay, at this point we can factor out dy dx. What remains, we'll have 4y for the first part and the 2 for the second part equal to 3 minus 4x. You can divide both sides by 4y plus 2. Okay, clearly that part can divide, and so remaining 3 minus 4x over 4y plus 2 if our manipulations are correct. Simple and straightforward, right? So far so good. Let's look at a part that involves a bit of some product. So I hope by now you already introduced the product rule, the quotient rule, because they get to be useful in these cases as well. So for the third one, x to the power 3 plus xy minus x squared y squared is equal to 7. I'll mention again, feel very free to try out this question. Alright, assuming you've attempted it. So the derivative of x to the power 3 is going to be 3x squared. Now you can say that xy is actually a product. So most of you would, if you see it to be a product as xy, what you do is you write, let your u be equal to x, let your v be equal to y. Derivative of u in respect to x is 1, derivative of v in respect to y is 1, except you added y dx when you differentiate your y. So from there you know the product rule. Some of you know the formula. Product rule y prime is equal to maybe u v prime plus v u prime. Okay, so knowing that addition and product and multiplication is actually commutative, it doesn't matter for me what I start with, and I'll just go straight right away, and I don't write this when I'm dealing with a product rule. I just go direct. So how? So for the first part, I'll just decide to get x, or I'll decide to get y. So y, if you get y, multiply by the derivative of x, which is a 1. Now if you start with x, you're supposed to multiply by the derivative of the other part, which is y. Derivative of y is 1 multiplied by dy dx. This is equal to what you're going to get when you are substituting that formula. Okay? And then again, for this one, you do the same. What we have is negative x squared y squared. If you want, you can forget about the negative, but even if you apply it there, it's still gonna work. Let's just leave it out for now. Derivative of x squared is 2x. Derivative of y squared is 2y dy dx. So we'll do that. For 1, let's start with x squared. Now remember there is this negative, so the negative applies to everything, so we are going to introduce some brackets here. So if I start with x squared, it means I'm going to multiply by the derivative of the other part, which is 2y dy dx, right? Plus, now I can start with y squared, multiply by the derivative of the other part, which is 2x. So don't forget what is supposed to be on the other side. So we have a 7. So a derivative of a constant is a 0. Let's try to simplify this. So we have 3x squared plus y plus x dy dx. Distributing the negative, we'll have 2y times x squared is going to be what? 2x squared y. Or you can, whatever you like, you can say 2y x squared dy dx. Again, this negative multiplied by the other part, it will be negative 2x y squared equal to 0. Now at this point we do a sum, get the parts having the dy dx to be on one side. So that means we have x dy dx minus 2y x squared dy dx. Everything else goes the other side. This part, which is negative, becomes positive on the other end. So we're going to have positive 2xy squared. Which other part do we have? This part, negative 3x squared negative y, all gets to appear on the other side. Now at this point things are easy and straightforward. So dy dx, after factorizing, you're going to remain with x minus 2y x squared equal to 2xy squared minus 3x squared minus y. And then you can divide both sides by this. On this end to divide, and whatever remains on the right, whatever has remained on the right is actually our derivative for the third one. Please, if you're tired, grab a glass of water and just relax. Okay. Now I'll move to the fourth one. X minus 5, the power 5, actually x minus y. X minus y raised to the power 5 is equal to x plus y plus 1. Very interesting question. Feel free to apply every kind of method you know. If it's chain rule, if it's quotient true, if product true, be at liberty. So we'll just differentiate each part. Now, what chain rule tells us is, assume there's a constant 1 there. 5 times 1 is 5. X minus y, reduce the power by 1, it becomes the power 4. Now, you don't actually end at that point. You're supposed to multiply by the derivative of what is in the brackets. Now, what's the derivative of x minus y? Derivative of x is 1. Derivative of negative y is negative 1. But when you differentiate y in respect to x, you add dy dx. So that just becomes 1 minus dy dx. So I'll multiply by that 1 minus dy dx equal to, on the other side, derivative of x is 1, derivative of y again is going to be 1 multiplied by dy dx, so it just be dy dx. Derivative of 1 is just a 0. So that's what we have at this point. So we can try to go a bit deep. So let's see what we can do. 5x minus y raised to the power 4 multiplied by 1 minus dy dx. Okay, we can take the dy dx on the other side. So that will be minus dy dx equal to a 1. Now, knowing that this is multiplication, we can go on and multiply whatever we have here with what is in the other brackets. Okay, that's the only way we're going to simplify this. So this term multiplied by the 1 there, it gives us 5x minus y to the power 4. Nothing changes. And then again, this same part multiplied by the minus dy dx, it will be minus 5x minus y to the power 4 dy dx minus dy dx equal to a 1. In case you haven't gotten it, I'll repeat. What I'm saying here is this part, since it's multiplication, it's a single term. Multiply this whole part with, first of all, 1 to give us that, and then multiplied by negative dy dx, it gave us this part. So at that point, we can remain with whatever was dy dx on the left. So we have minus 5x minus y, the rest to the power 4 dy dx minus dy dx is equal to 1. Now this other part as well can go the other side. It becomes minus 5x minus y raised to the power 4. What do we do at this point? Factor out dy dx. For the first part, what remains is negative 5 x minus y raised to the power 4, and then minus just the 1 for the other part, equal to 1 minus 5x minus y raised to the power 4. So we divide both sides by what's in the brackets. So that's negative 5x minus y raised to the power 4 minus a 1. And so this part will actually divide by the same. So that we can actually just divide. And so whatever is on the right is our derivative for the fourth one. Okay, so at this point we've noticed that actually when you're dealing with implicit differentiation, every part of the derivative is differentiated in the normal way. The only addition is we actually have to add dy dx at every point where we differentiate y. Okay, that's basically what happens when you have y is equal to x squared. Derivative of y is equal to x squared is going to be, derivative of y is 1 multiplied by dy dx. So dy dx is actually equal to 2x. So this is exactly what the principle we've been applying at every point. Okay. Out of curiosity, try out this. 2 is equal to 4x squared. What's the derivative there? So derivative of 2y would be what? That would be 2 multiplied by dy dx is equal to 4x squared. Divide by 2, dy dx becomes 2x squared. So which is also good if you are divided before actually differentiating. That would be a 2 ahead of time. Let's see what we've done here. This is supposed to be 8. So to divide by 2 it becomes 4. So that even when you decide to divide by 2 ahead of time, your dy dx just becomes the same value again, right? So that would just be dividing by 2 would give you something like what? A 2. So it gives you a 4x if you are to differentiate it directly. So either ways, all the ways are going to be okay. Look at number 5. You are free to pause the video and try that interesting question out. So we have x is equal to 2y over x squared minus 1. How do we go about it? So I know we are familiar to crossing and multiplying. I want to use a different language, but actually doing the same thing. So multiply both sides by the denominator x squared minus 1, even that side x squared minus 1. So on the right hand side, this is going to disappear. On the other side, we're going to have x multiplying with x squared minus 1 equal to 2y. So we have x times x squared is x squared, x to the cubed minus x is equal to 2y. And then at this point we can just do the needful. Derivative of x to the power 3 is 3x squared. Derivative of minus x is minus 1. Derivative of 2y is a 2. Now dy dx, because we've differentiated y, divide both sides by 2. And multiply by 2, or multiply by 1 over 2 both ends. So our dy dx becomes 3x squared minus 1 over 2. Simple and straightforward. Then finally on this question 1, we have x squared plus 3xy squared minus y to the power 3. Who gives a very simple question after having done the complicated ones? Okay, so please pause the video and try this one out. Just ensure that you build some confidence, that you are very sure you've understood what we've done so far. Derivative of x squared is 2x. Derivative of 3xy squared, that's a product. So 3xy squared, I can divide that in two parts, 3x and y squared. Derivative of 3x is a 3. Derivative of y squared is a 2y dy dx. So I'll start with 3x, multiply by the derivative of the other part, which is 2y dy dx. And then the second part is y squared, multiplied by the derivative of the other part, which is a 3. Now we are on that part, negative y to the power 3, that's going to be a minus 3y squared dy dx. Derivative of a 9 is a 0. So we have 2x plus 3x times 2y is a 6xy dy dx. That's going to be a 3y squared. Then we have 3y squared dy dx equal to 0. Let's group the parts that are having the dy dx on the same side. So I have dy dx. I can go straight, actually let me try to do this. I can go straight and just pull out the dy dx. So for that part I'll remain with 6xy, and this part I'll remain with negative 3y squared. And then what I have on the other side are the remaining parts, that's 2x, and then this part. So actually it will become negative as they go the other side. Dy dx becomes minus 2x minus 3y squared over 6xy minus 3y squared. So we want to hear how these videos are helping you. So if you've got a comment on the way we are solving and the way the videos are, please feel very free to comment on any of our videos. Start with this very one. Give us a comment on how we've handled these questions. Okay, and that marks the end of question 1.